right. Okay, thanks everybody for coming. My name is Michael Robellard, and I'm going to be giving a talk today about the evolution of an event recording system that I wrote at the company I currently work for. So I am the Director of Technology at a company called Noggin LLC. We're a startup in Cleveland, Ohio. And we make a product called the HR Tutor. It helps nursing instructors learn to use, oh my God, did I leave that on there and say ORMs? That is not what it does. I think I had that on my slide. I think I copy and pasted that from my slide last year. Electronic health records, not objects relation. I do a lot with those, so it can confuse. I was also the former senior software architect at OnShift. I see some of my fellow ex-OnShift employees here, so I used to work there as well, which is a good company if you're looking for a job. Unfortunately, Noggin is not hiring at the moment, but I think OnShift is, so go work at OnShift. All right, so the problem we're going to talk about today. Almost everybody has used Google Analytics if they have a website. And it's an awesome tool. It records page views and visits, and you can even record custom events on your website. And it does all this stuff. There's one problem with it. You can only use it for aggregate data. You cannot track individual users with Google Analytics. It is specifically against their terms of use. And unfortunately, or fortunately, depending on how you look at it, we need to do that quite a bit. In our case, we needed it for a few reasons. We wanted to be able to track our what our users were doing on an individual user basis for our customer success team so that they could find out if the users are actually using the software and where they're having problems and where they keep going and things like that. For the instructors, our course is it's an educational thing. The instructors need it for an audit log so that when the student says, I did this work. And the teacher says, no, you didn't. They want to be able to go and look and say, well, look here, you did not do this when you said you did it. We actually had a case of that where we had to give information to the teachers because they were going to fail a student because the student had lied and said they had done the assignment at a certain date, and they had actually done it like 2 weeks after the due date, and they said they'd done it before, and they got into all sorts of ethics committee violations, and it was a mess. But luckily we added this feature and it allowed us to be able to track that information very precisely, and that helped them be able to prove that the student had in fact not done what they were supposed to do when they were supposed to do it. And it also helps us on the dev team. If there's an issue and we're having a hard time tracking it down, we can go and look and see what steps the user took to get to that point. So there's lots of good reasons for this. We're not doing this for the big brother. We want to, know everything and track everything about you. We've got legitimate reasons why we need per user tracking for stuff. So before we get into this, I want to talk a minute about the environment that we're running in, because that obviously is going to affect the options that we have and how we're going to solve this problem. We're a Python shop, clearly. That's why I come and talk at PyOhio all the time. In fact, we just moved to 3.5. Be happy to talk to anybody about that later if you want. It was an interesting challenge. We use Postgres for our database. We're using Tornado as our web framework. And our entire production environment runs inside AWS. So we have an RDS database for our Postgres instance. We have 2 web servers behind a AWS load balancer. And so everything's in AWS. All right, so how do you solve this problem? One way you could solve this problem is we could solve it by buying something off the shelf. We looked around, there's some things out there. There's some product called Mixpanel. You get paid $150 for 500,000 events in a month or something like that. There's some consulting companies that will help you with solving this problem. And there's other ways you can do that. If you go digging around, there's lots of different companies that provide ways to do that. So there were some reasons why we didn't want to go down this path. First of all, we're a startup. We don't have a ton of money. So in one case, one of the things is our, we still are at the phase where developer hours are generally easier to acquire than spending money on things. So the other thing is that once we do if we were to do all this, we'd have to get all the data in one place. So, because we want to be able to take this data that we're going to put in the events and join it with other data that we have in our database. So that would mean we'd either have to, if we're using one of these technologies, we'd either have to move some of our data into their database to join it, or move their data into our database, or move both things into a data warehouse. All those are costly, kind of expensive options that would add more time to the actual what would be required to do. So we kind of nixed that idea. Another way we could have done this, which is a pretty common way to do this, is we could have just taken the logs that we already have and parse them. Which, there's some nice things about this, which can also be bad things about this. We could do it offline, and we already have the logs. We don't have to collect that information. But the thing is, log data is somewhat limited. It gives us a lot of the stuff that we're tracking. It gives us the agent string, so we'll know exactly what browser they're using. And it gives us the URL they hit and the IP address they came from. And those are all great things to have in there. But for instance, if we wanted to if we want to keep the post data for form submits, that's not tracked in logs by default. And then also, that's not sort of a real-time solution. I mean, you could come up with a way to do it in real time with, sending logs to a database, or, there's crazy ways you could do that, but by default, it's not really a real-time solution. So, we really don't want to do this log parsing thing, so we said, nah, that's not that. So another way we could have done this, which is kind of the first default implementation, I've seen companies that do this, is, okay, we could just say every time there's a page, hitting the page, we can go and say, we're going to just go and add a line that goes and inserts all that information into the database once per page. If you're getting 100 page hits a day or something like that, who cares? Your database isn't going to have a problem with that. If you start to scale, though, it doesn't take much to scale to the point where that's going to cause a problem. And so you don't really want to do that because you run into scaling problems pretty quickly with that. So we were like, well, we're using AWS for all our stuff. Let's look at how we could solve this problem using AWS's tools. And AWS has some pretty cool tools for this. They have this Amazon Kinesis thing that allows you to handle the streaming data, and you can put events on the Kinesis stream, and you can pull those events off the Kinesis stream and put them, if you're using Redshift, you can do it directly, or you can send it to Amazon Lambda, which is a serverless thing, and it can do Python and a bunch of other languages, but we only care about Python. So there's a lot of really useful things that we could do to help us solve this problem with Amazon. So we started digging into how we would solve it this way, because it seemed like a good idea. So what would we need to do that? Okay, so the first thing we need to do is we'd have to write an Amazon Lambda function to take the Kinesis events off the stream and stick it in our Postgres RDS database, because we weren't going to spin up a Redshift database. It just, once again, it wasn't really in our budget to do that, but we already had a Postgres RDS instance. But Kinesis doesn't go straight to RDS, so you'd have to write a Lambda to make that. Well, unfortunately, and this may have gotten better. This was 6-9 months ago that we looked at doing this. Talking to RDS databases via Lambda, it's not straightforward. Getting the PsychoPG connection to work, they just fixed the fact that Lambdas didn't have VPC access. If you know anything about AWS, you might be aware of things like that, which they just fixed. It wasn't going to be, it could be done. Found some examples where people had done it, but there were some hoops that you have to jump through to get it to work. And then the other issue is testing it in Lambda is also not simple, because you have to actually run your Lambda code there's not like a test Lambda environment you can run locally to test this with. You have to actually run it in Lambda to test it. There would be some extra testing steps we'd have to sort out. Then the other thing that we would need to do is, you'd probably track this just like, Google Analytics thing through JavaScript. So we had to write some JavaScript. The next step would be to write some JavaScript to track the events and put them in the Kinesis stream. Or the other option is we could also write some Python code so that on the page load, on the gets and posts in the page, we can place it in the Kinesis stream, which, for me, I'm a Python programmer. I'm not a huge fan of JavaScript, so whenever possible, I prefer to write Python code to JavaScript code. And we were looking at using this as our method of doing it. So there's some Python libraries for writing to Kinesis. You can use Botto to do it. There's also a library called Python Triton, which allows you to send things to Kinesis, but it kind of batches them up for you automatically, which sounded really useful to us. We didn't want to have to send each individual thing onto the Kinesis stream and have to wait for it, and batching it sounded like a good idea. So we went and started looking into that. So we were like, how does this thing work? Well, it ends up that it uses something called ZeroMQ to put the data into the worker process, into a worker process. So it spins up a separate process, and it goes and you make your call, puts it into this worker process. The worker process batches up 100 of them or something and sends them off to your database 100 at a time. Well, that sounds pretty good. But wait a minute, it's using ZeroMQ. That's a queue, right? I've used queues before. Like the slide says, a couple years ago, I actually did a talk on RabbitMQ here. So, I know something about queues. This could actually be useful. So we went and I kind of dug into what is this ZeroMQ, because I hadn't used it before. I'd only used RabbitMQ and Celery. And this just seemed like a really potentially useful technology. So I was like, So I went on their website and started reading. They have a really, really, really awesome guide. In fact, it's one of the better technical documentations I've ever read for an open source thing. So if you like reading good documentation, this is actually really good documentation. And it also has some really interesting, simple to use APIs. It's written in C, but it has bindings for Python and PHP and every other language under the sun, including all the new fancy ones that, all your young friends like to talk about. And on top of that, because it's written in C, it's really fast, and it's asynchronous, which, since we're using Tornado, we like asynchronous stuff, so that was kind of cool. And the other thing that's really cool about it is this bottom thing. You don't need a broker. You can go and you can write your ZeroMQ to say, here's my worker process, and here are the things I'm going to feed to it, and they can feed straight to the worker process, and you don't have to stand up infrastructure and worry about all the kind of infrastructure things if you're running a RabbitMQ, and that can be a pain. Ask Will in the back, because he ran our RabbitMQ stuff at OnShift, and it was a pain. Okay, so how do you use the ZeroMQ thing? It's pretty cool. It's weird though too. It has like the socket API. It's kind of like you're using old school socket stuff to do higher level things, which is kind of interesting to wrap your head around, but it also makes it fairly easy to grasp because you just say, hey, I want to listen or I want to connect, and then I'm going to poll, and I'm going to send and receive messages. And it's very, that's what makes it simple, but it's also kind of interesting because it's not like most other things where it's like, oh, you're going to send a message and then we're going to go read from the queue and stuff like that. It kind of just says, we don't need to have all that extra talk. We'll just use words that people that have done low-level programming understand and stuff like that. So I thought that was kind of cool. I guess it could make some people a little nervous if they have not done things like socket programming before, but it's really not bad. The other thing that's really cool about it is it doesn't care about transports. It will work, it'll work within a process. It has, these are the different, when you select the transport, you can say what you want. So you could do, in-process stuff, you can do IPC, you can do TCP. This PGM and EPGM, that's multicast support. So if your network supports multicast, you can actually use multicast within this, which is kind of cool. I haven't played with that yet. I actually love to play with it because I think it sounds really cool, and I've always wanted to do something like that. I know how to do multicast. I haven't done it yet, though. And then it also allows you to do different types of things, which if you look at RabbitMQ, if you know anything about RabbitMQ or other queuing things, you have things like fan out and, and all these different kind of paradigms for how you can set up your queues and your routing in your queues. Well, ZeroMQ, because of the way it's a kind of slightly lower level than Rabbit, so it doesn't have those, but it has all the building blocks you need to build those, and you can build things in really interesting ways. So, it has the traditional pub sub, which is what we ended up using for our stuff that we'll show in a minute. And then you can do kind of a more normal TCP, just like two TCP connections, request reply type thing. And then there's this push-pull router deal, which the router deal lets you do like fan out and things like that. And the documentation explains a lot of this in detail. I'm only going to be talking about pub sub because that's what we ended up using, but it's really cool to read and it's a really good read. So if you're interested in read it. Now, I said it was asynchronous before, so we got to talk about how it's doing the asynchronous stuff. So it is multi-threaded code. It uses it spins up a thread. It spins up threads to handle the work in the background for queues. So when you send a message, you actually don't send a message across the wire right away. You send a message, it puts it on a local queue on your process that's sending it. And then the thread in the background that's handling the sending the messages out to whatever your worker process is, at its own leisure, basically goes and sends pulls the stuff off of the internal queue, sends it across the wire, and then on the worker process side, there is, once again, another thread. That thread pulls it off the network wire and puts it into another local queue on that end, and then when you actually read messages, you're reading the messages off of the local queue, not off the wire. So one of the big things ZeroMQ is doing is it's hiding all of the networking stuff under this other kind of layer above it. But it, you say, oh, it's multi-threaded. Well, we're going to have problems with that because we've got a global interpreter lock in Python. Well, the thread is running in C, so the global interpreter lock never has anything to do with it, so it works great. So that is also not an issue. So I thought about this and how this thing worked, and I was going to use it with this Python Triton thing, and I just kind of went down this rabbit hole because I'm into queues and I wanted to learn about it. But I was like, we can solve this problem and take out all of the AWS specific stuff and come up with a simpler solution that is just as scalable as the AWS one, doesn't rely on AWS. Not that there's anything wrong with relying on AWS, but we don't have to rely on AWS. We don't have to set up the extra infrastructure inside of AWS. We don't have to build the Lambda and stuff. So how could we go ahead and do that? So what we ended up doing is on each of our production, the way it works, on each of our production web boxes, because we have 2 of them for redundancy in our production environment, when we start the web process, we kind of start on the side another process using multiprocessing that is our worker process. And that worker process just kind of runs a ZeroMQ little server application. It sits and listens for messages to get sent to it. And, our web application will then go send those messages every time that we want to put an event on there. So it's generally every page, we can do it any time, but we generally do it on every page load, and whether it's a get or a post or anything like that, to track what was done. And then what happens in the worker process is it gets those things, and then there's a timeout set on it. I think we have it set for every second, but we could adjust that timeout as we want. In every second, it takes everything that's been acquired and goes and writes it to the database. If we want that to be 5 seconds or 10 seconds or half a second or however we want to do it, we could do that. And then just writes everything to the database with one insert. So, anybody that knows anything about Postgres, it's going to be way faster to do one insert of 100 rows instead of 100 inserts of 1 row each. So it ends up saving an awful lot of work on the database. And if we wanted to do something on the JavaScript side, so if we wanted to have client-side tracking of, oh, this person clicked on this button that goes and does something, we can still do that. We just go and add a really simple, we have a really simple little piece of code that goes and says, hey, I've got a click, it sends a GET request to a URL on our application. It's an actual, since we're using Tornado, we can do asynchronous things, so we do it completely asynchronously. It immediately, as soon as it gets the request, the very first line is end the request. So it doesn't do anything, it ends the request and sends the 200 back to the server, so if there's anything even waiting on it, that's not an issue. And then we go ahead and post it to the process, and send the message, and then the message gets received. So it's really fast to go and handle those click events that way. And since you're doing them, you would be doing them with like an AJAX, you could just not even bother. You don't even need to wait on the JavaScript side for the response. So, which is what we end up doing. We don't even bother listening for the 200 response. We just send it and assume that it happens. So, that's kind of the basics of how the solution is that we ended up coming up with that we use. And so I'm going to show you, this is kind of, it's a little simplified, but this is pretty much the exact code out of our worker process. Hopefully everybody can see that okay. But yeah, so basically what we do, this is a process that gets created, and it's very simple. You've got it's using multiprocessing to spin it up. So it inherits from process, and the very first thing it does is it sets up this ZeroMQ context, which kind of says, I'm going to be using ZeroMQ. These are, please build me a context for using ZeroMQ. And then I want to use it, and you can have multiple sockets in a single context, but we only need one in this case. And we're going to be subscribing, that's what that thing is. So we're going to subscribe to somebody's publish request. And then we want to listen on, port 5556. Just random port number I picked. And what we're going to do is we're going to subscribe to everything. That's what our empty string there means. We're subscribing to every single message that comes across on port 5556. So you could change that and you could say, I only want to subscribe to messages about, posts. And you could have one for posts and one for gets, or, however you wanted to do that. And then we have this last time thing. This is so that we can go and keep track of the timeouts. And then we just kind of start an infinite loop here. We poll for messages, and if there are messages, we read the messages. We do some JSON decoding on those messages. And then we go and we look at the current time and compare the times, and if the times are different, then we go, if the times are within the interval range, then we go ahead and tell the database to take everything that we have received. Oh, I forgot to mention this. I guess, this line up here. We go. This is actually probably the most important line. We go and put the. We have a list out there, and we just go and put each of the events in the list, and then we just kind of flush the list every time there's an update database. And then we have another thing on here so that if the program ends, which is it just so happens that you'll get a keyboard interrupt if the multiprocessing, when the multiprocessing shuts down, you'll get an exception for a keyboard interrupt. So whenever we get that, we send one last update to the database to pull everything that has been read up to that date so we don't lose any data. And that is the entirety of the process involved for the worker process. And the client's even simpler. We just have, it's basically, I use class methods here because it's kind of a simple singleton. I just need one client to use here because we don't have to have one client per request or anything like that, because we're just sending idempotent messages, so we don't have to deal with any of that kind of craziness. So we didn't need pools or anything like that. So, same kind of thing. We tell, hey, we need a context. We need a publishing socket instead of a subscribing socket. And we're going to connect to localhost 5556, which is the one that we're listening on for the subscriber. I could have done this with IPC instead of TCP. I just chose TCP. From what I read, there's really not a whole lot of performance difference between the two because they're essentially almost the same thing in Linux anyway, when you're talking on localhost. So, I chose TCP because I at least understood everything that was happening in TCP. And then all you do when you send an event, we literally just JSON dump the event object to a string, and we send the string over, and it gets read on the other side and gets we do a JSON load on it and put it to be written to the database. So it's very simple what the client does. The one more thing we have to do is, since I'm starting the worker you could run your worker process as a completely separate process and use supervisor or whatever your process control mechanism of choice is and start it separately from your thing. But it was easy enough to just use multiprocessing to start the event server as a separate process as a child process off of our Tornado process. So we did that, and then that also gave us kind of the added benefit of if we restart in development, we continually we have auto restart on, so when we auto restart, it would also auto restart the worker process. So that was kind of a nice side benefit, and that's why we had this add reload hook kill server, so that anytime Tornado has a reload, it goes and restarts the worker process as well as our Tornado processes. So I was going to actually try and get some numbers and stuff, but I don't have great numbers to talk about for the scalability, but I did run a couple tests. We use it every day in production, and we've never had a problem with it at all. So I tried to make some quick tests to kind of show what you could do with it, and it was being a pain in the butt. But what I did manage to get is I managed to put, I just took 10,000, I literally ran a loop and stuck 10,000 events into the thing, not even waiting for web requests. I just literally spun up a server, spun up a client, and put a loop, put 10,000 requests in there, and it was able to handle all of them within like a second and a half. And that's including I tried scaling it up, and it started to have some issues past that, but that was mainly because I wasn't handling the shutting down the sample code I built. I wasn't handling the shutting down and making sure I was cleaning out the everything that was in the queue. So the queue would still have stuff that wasn't in it, so I couldn't really test the scalability as much as I wanted. I wanted to see how long it would take for like 1 million of them and stuff like that. But even 10,000 within a second and a half. If you've got 10,000 page loads in a second and a half, why hasn't Google bought you yet? And that's one server, and that's on a per server basis. So, even with that, I was pretty happy with it. I don't think there's going to be any issues with scalability on that piece of code. I felt pretty comfortable when I did that it's like this is going to work and going to be scalable for what we're going to be doing with it. So, we went through this process, and, after I went through this process, which is kind of when I came up with this idea for the talk, I was like, well, what did I learn? What did we learn from this whole process of doing this? Because there's lots of ways we could have solved this problem. The best thing that I learned is it kind of validated to me that we made the right choice by, instead of just going with the first thing that you thought of and implementing it that way, that's not always the best choice. Spend a little bit of time, look at what the solutions are and how the solutions work, because sometimes you're going to look in those solutions and find a better solution. And, I think the whole thing took me a couple days to write. I have a feeling the Kinesis, if I had gone down that Kinesis and Amazon path, probably looking at least a week to write. So I probably saved, I don't know for sure because I didn't implement the Kinesis one, but I'm guessing I saved several days of work at the minimum by doing it this way. And I learned a cool new technology on top of it. So, my first thing is, it's definitely worth the time to spend time thinking about things, not just jump headfirst into the first solution you come up with. The other thing that I learned is ZeroMQ is a really cool lightweight queuing mechanism. I've used Celery and RabbitMQ, And I know there's a bunch of other ones. I heard somebody talking about Kafka the other day, and that was kind of an interesting sounding thing that we haven't looked at before. Queuing is a really useful technology for offloading work, especially in web processing when you're doing web stuff. And having a lightweight option instead of the big heavyweight options is really useful to have. And the other thing is our solution. Looking back on it, because of the way that solution's written, and it's very simple. We can go and we can add to it pretty easy, and we could very easily say, we're going to change it, and we're going to make it so that we can have different types of events. Right now, we just that one thing subscribes to all events. So we could have it just subscribe to one type of event and have another type of event for emails and have something that processes our emails offline instead of as we're sending them. We can do things like that without changing a lot of that code that we wrote. We can add to it. And if we run into problems where it starts to not work on the same box as our web boxes, all we have to do is change that URL that we're connecting to, and connect to a listening instance on a whole nother box, and we've got multiple boxes using it, and it would be it's 1-2 lines of code change to do that. So I think it's a pretty scalable solution. I think it's easy to grow. We can change it as we want to, and the other thing is since it doesn't rely on AWS stuff, it's very easy to test locally. I can spin these up on my local machine, test it, see how it's working. If for some reason, tomorrow all of a sudden AWS raises their prices by 1,000% and we can't use AWS anymore, I'm not stuck with vendor lock-in as well, which, I've had that problem with some other technologies before that has caused me problems, and so that's another good thing that's useful to have. So my talk's a little bit shorter than I think I wanted it to because he hasn't even brought up a single thing. But that's okay. I will be happy to take questions. My presentation, as you can see, is available online. Feel free to email me. I have a Twitter account, blogs, Facebook, LinkedIn, all that wonderful stuff. So lots of contact information if you want to talk to me. And any questions?
Server dies, you'll lose those. Is that accurate? Do you care much about that in this case?
Yeah. So the question was the durability and what happens if the process dies and are the events lost. So in our case, we didn't, because all we're doing is recording events. If, like you said, if it dies, we didn't really care all that much. The chances of it causing a problem would be minimal because it is just event data. It's not like it's transactional data that is incredibly important to the business. So it wasn't a huge deal to us. There are, when you read the documentation in ZeroMQ, they address this specifically and give you ideas of if that is an important problem to solve for you, how to solve it. One of the ways that they do solve it is by adding basically you create your own broker or broker type thing that goes and says every single event that I get, I'm going to go record off to a disk or Redis, wherever you want to, wherever you decide you want to temporarily save it so that you don't ever lose those messages. And they do talk about that as one way to solve that problem. So people have solved that problem with ZeroMQ. We didn't need to solve it, so we didn't solve it, but it can be solved with ZeroMQ. Any other questions? Yes.
Kind of related to your talk, but not really. Once you get all this data, how much of this data do you sit down with your executive management team and like the user experience team to figure out how to make the product more useful?
So this is a new thing for us. And so the first thing we decided we needed to do was collect the data. We are still we've used it several times, mainly right now for debugging and for the instance I mentioned before about the student that the teacher called and said, hey, the student is telling me one thing and I am seeing something different. So we were able to use it for that. We are planning to use it. This was kind of our first step, and our next step is to try and figure out how we're going to turn this into dashboards and useful stuff for our customer success team. It's really, really, really important to us because our company is very customer-centric and customer-focused. My partner, she's very into making sure our product is just what the customers want. So we are planning on working on that. We just haven't gotten that far yet. But it is something that we want to do a lot more with it. But we had to collect the data first. So that was step one, was collect the data. Now step two is do stuff with the data. Yep.
Can you describe like the types of events or examples of the events that you're collecting?
Okay. Okay, so the question was, what types of events are we collecting? At the moment, the events that we are collecting we have three types of event. Every get and every post is getting recorded. Basically, it's the exact same type of information that you would get with Google Analytics. We record the agent string, we record the the fact that it was get or a post, the IP address it came from, the actual URL that was but we also record the user ID of the user that did it. We record the what we call it the school ID, but it's basically what organization is that person attached to at the time that they were doing it. And then we also record if it's a post, we record the inbound post variables. So we keep all that information. And we do that for get and we do that for post. And then we also have a very simplistic click tracking, similar to, it's basically what I described, where we can go and send a JavaScript, an AJAX request to a URL that basically tracks the same type of stuff plus whatever we put on, whatever we say was the thing that got clicked on, so that we can say, the place that we actually use it now is our help, on our help system. So we have on our help thing, when somebody clicks on a help thing, there's a, was this helpful, yes or no, and if you click yes or no, it sends that, and we can track whether or not the stuff was helpful. So that's what we're currently tracking. But we could track, all kinds of events. We also track all the status. So we know if it was a 200 response or a 500 response. So if there's an error, if it did result in an error, we happen to have that there. And we have other things that actually we use for our error tracking. We use Sentry for actual error tracking, but this way we can and I think we actually record I have to look, but I think I record the event ID in Sentry, so you can link the two things if there's a 500 error. If we don't, I need to be doing that because I meant to do that and I just never got around to it. All right, any more questions? All right, well, I appreciate everybody coming and listening to my talk. Sorry it wasn't longer.